6.1 video deals with combinations. A combination is basically something where the order is not important at all. And for example, we're talking about trading cards. Suppose you have a bunch of trading cards. It does not matter what order they are in. It's just the point that you have trading cards. And when we're talking about a combination, we have an equation here where we have something like this, where we have N and then a big C with an R. And the equation is N with a little exclamation point over N minus R exclamation point and an R exclamation point. And what the exclamation point is factorial. The N stands for the total. So if we're talking about trading cards, it would be the total amount of trading cards that you have in your hand. And then the R is the number of the objects taken. And so what we're doing here is we're going to use this equation to figure out some possible combinations that you could possibly draw from a stack of trading cards, or if it was something else, a deck of cards. So for example, just a basic problem. Suppose we have the N equals 3, which is our total amount of objects that we have. And we want to know what the combination would be if we drew 2. So if we use the equation, we would write 3 factorial over 3 minus 2 factorial, and then a 2 factorial. And what this factorial means is basically counting down. So we have 3 times 2 times 1. 3 minus 2 is 1 inside the parentheses, so it'd be 1. And then 2 factorial is 2 times 1. And as you can tell, the 2's cancel each other and the 1 cancel each other. So we're left with 3. So the answer for this combination would be 3. Now there are 2 ways to do it in your calculator. Here's the first way. You can always punch in the number. Let's say we had this as our problem. You can punch in the number 5. And the way to get that factorial symbol is you want to push math. This is something very important for you to write down in your notes, so you know. You're going to scroll over to probability, and you're going to go down to number 4. And that's going to give you this exclamation point. Division, and then the 5 minus 2 in parentheses. Again, go to math, probability, number 4 to get another one of these symbols. And then you punch in 2, and then get another one of those symbols by hitting the math probability number 4. Now, that's a lot of buttons to have to push, but when you do push enter, you get the right answer. Here is another way that you can do it in your calculator, and it's way easier. So what you're going to do is you're going to hit 5, math, go over to probability. Instead of hitting number 4, you're going to hit number 3. And that's going to bring up the equation with the combination. And then you're going to push 2 so that you can type in the 5 and the 2 from the original problem like we had. And push enter. And then you'll get the answer that way as well. This way is so much easier. But I do want you to realize that you can get the factorial button if you choose to do it the long way. All right, so let's jump into some of these examples, and these are very real life. So the first example says, find the number of possible 5-card hands that contain the cards specified from a 52-card deck. So we're dealing with a deck of cards. And we want to know, what we're going to get when we have 5 face cards. How many possible 5-card hands that will contain 5 face cards in them. And face cards are the ones that have faces on them, like your kings, queens, or jacks. How many total kings, queens, and jacks are there in a deck? Well, there's one per suit, so there's 4 suits. You have diamonds, clubs, spades, and hearts. So you would have 4 kings, 4 queens, and 4 jacks total. And so when we do this, how many are totaled when we have face cards? There's 4, 8, 12. So we have 12 total. That's going to be the N. We're taking a combination. And the amount that we want is 5 of those. So those are the objects that we're taking. And so again, you can just plug this in the calculator like I showed you. You're going to type in the 12. You're going to go to math. Scroll over to probability at the top. And you're going to go down to number 3. And then you're going to push the 5. And you're going to push enter. And when you do that, you should get 792. So there are 792 possible 5-card hands that would contain 5 face cards in them, kings, queens, or jacks. All right, now here's another example. Let's say we wanted 1 ace and 4 cards that are not aces. So we have a stack of 52 cards, and so we have 4 aces in that stack of cards. So we are taking 4 aces. There's a total of 4 aces, and we want a combination of 1. Okay? That's going to cover the 1 ace part. But now we need 4 other cards that are not aces. So if you take the stack of cards, which are 52, and you minus those 4 aces from it, you have 48 cards left over. So we're going to multiply this combination by the other part, because this is the 4-card part. We have 48 total objects left. We're going to see what the combination would be if we took 4 that are not aces. So all of these 48 cards are not aces, and we want 4 of them. And when you do this in the calculator, you could do it the same way. You know, you could figure out this answer first, and then you could figure out this. The answer that you come up with is a very large number. So there are 778,320 hands that could be dealt with to you that have at least 1 ace and 4 other cards that are not aces. All right, now we're talking about Pascal's triangle. This is kind of like a switch, and it is about combinations. And what Pascal's triangle is, and you're going to get a handout in class, is a triangle that allows us to kind of do a shortcut and figure out patterns to a whole bunch of different things. So the way they do this, they start at the very top of the triangle and they say, if we had 0 total and we're taking 0 objects, okay, we would get an answer. And then we go, what if we had 1 object, but we took 0 objects from the total? What if we had 1 object and we took 1 object from that 1 object? And then they keep going on. And what they have done is they have created, actually Pascal has created, a triangle with all of these answers. He went through and got all of these answers for all these combinations. And what he did was he came up with a pattern. These are all the answers from our calculator, and you can go out and test these out to see if you get the same thing. He came up with a pattern that looks like this. And we could go on and on, because what he noticed was, if you see the triangle here, all of the outsides are 1s, every single one of them. Now to get the insides, he took 1 plus 1, which gave him 2. Now if you go down, 1 plus 2 is 2, 2 plus 1 is, or I'm sorry, 1 plus 2 is 3, and then 2 plus 1 is also 3. You go down to the next row, you have 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So he found a pattern, and he was able to keep going with all of these rows. And he said, all right, this is when you have 0 as your n, 1 as your n, 2 as your n, 3 as your n, 4 as your n, and he kept going and going. And so if we look at the next pattern or the next row, which would be the number of objects total would be 5, we would have 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then we write that 1. And he went on and on and on. So if we wanted to find an answer very quick using Pascal's triangle, and I'm just going to throw one up here. You know, let's say that we wanted to find this combination. We have 2 objects, so n equals 2, and we're looking at just taking 1. So what you're going to do is you're going to go to the n equals 2 row, and we're looking for taking 1 object. Remember, this is 0, 1, 2. So that is the answer. You didn't even have to use your calculator or do a bunch of punching in or anything. Now, there's other ways that we use Pascal's triangle, and I'm going to show you that now. We're going to use the rules of Pascal's triangle to write the binomial expansion. And let me just explain something to you. This x plus 3 raised to the 6th power, remember you can't just tack on a 6 to everything and call it a day. It doesn't work. This is an expression, and it stays by itself. It is 1. It never goes, you know, this plus sign never goes away. So what this is saying is that we have x plus 3 times x plus 3 times x plus 3 times x plus 3, x plus 3, and x plus 3. Okay? Typically, you would have to go through and do the FOIL method, and then take that answer, multiply it by the next one, and you'd be sitting there for quite a while for this one problem. But because of Pascal's triangle, we have found a shortcut to this rule, so that we do not have to go through and do all of this multiplication on our own. And if we follow the equation that they give us, and this is in the book, this is a general equation, which is what we have over here. You know, of course, our A would be x, our B would be 3, and our N would be 6. What we're going to do is look at Pascal's triangle, and we left off over here, oops, sorry, at n equals 5. So our n in this case is a 6. So if we just went one more row and figured out what that was, we have a 1 on the outside, of course. We have 1 plus 5, which is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. And then we have 5 plus 1, which is 6, and then our 1. All of those numbers that you just found are all of the coefficients that are going to start this pattern. So here's what I'm talking about. I want you to write down exactly that pattern. And I want you to leave some room in here. So we have 1, okay, so we know that when we multiply x plus 3 6 different times, we're going to have a very long polynomial. This is just the start of it. Now, going to put your x after each one of these. And you're going to put your b. So just throw in the AB after every single one of these. Okay, now we need some exponents because we know that when we multiply x and x together, we get x squared and so on. So we're going to start with the highest degree, which involves our n. And that's going to go on the x's. So you're going to start with a 6, then you're going to go to a 5, then you're going to go to a 4, a 3, a 2, a 1, and then none. Now, you're going to start kind of the opposite with the 3. So you're going to start with the 3 down here with the 6, 5, 4, 3, 2, 1, and none. And this is actually going to be a 0. I better put the 0 just so we can see it. All right, so now you have it set up, and we just have to simplify. So if you look at this first term right here, we have 1, and what is 3 to the 0 power? That also is 1. So really, we just have 1 x to the 6. You don't even need to write that 1 if you don't want to. Now we move to the next one. So we take care of that. We have 3 to the first power, which is 3, times 6, so that's 18. And we have x to the 5th. Now that one's taken care of. We move on. 3 squared is 9, and 9 times 15 is 135. And then we have x to the 4th. Now we have 3 to the 3rd power, which is 27, and we multiply that by 20. And that's going to give you a 540 x to the 3rd. We're going to keep going. We have 3 to the 4th power times 15. And I'll tell you that's 1,215. And then you have your x squared. Okay, next. And I'm running out of room, so we have 3 to the 5th power times 6, and that is 1,458. And then we have x to the 1st power, so just x. Now we have 3 to the 6th power times 1, which is 729. And remember, this x to the 0 power is just 1, so you don't write it at all. So now, without having to do all that hard work for multiplying with FOIL, you just found the answer using Pascal's triangle. All right, here's one more example. I want you to write this down and be ready to do it in class tomorrow. So I will tell you that the n equals 4. Your a is going to be w to the 3rd, and your b is going to be -3. Okay, in this case we have a negative sign, so that we have to make sure we put the negative where a b is. Try to use Pascal's triangle. We already have n equals 4, so you know what the coefficients are. And then I want you to try it on your own. And if you can't get it, that's okay. But we are going to do this in class so that everybody can see it again.